Hello everyone, I am S. Roy. Let's continue our Haskell lecture. Today let's start lecture 2, and this is our textbook, 7 languages in 7 weeks. I'll be using some of the material from Haskell chapter in this lecture as we did in other chapters. Table of contents, let's first revisit some of the topics which we covered in lecture 1. And here is one function. The function name is double, takes one parameter, and this is the body as the name suggests. Now if we want to check the type of this function double, we type :t, then the function name, and we do it on the Haskell console. And this green line is the response from Haskell console, which says the function doubles, type information is this, and how to interpret this information. The first part that just means a is like a number, and then this is a separator, and this is the second part, and that is actually the main type information of this function. The first part is about the input type, so a is the input type, and after arrow we have the output type, and we see that output type is exactly same as the input, both are a. That is how we interpret the type information. And now if you understood how to interpret, you should be able to say which of these three statements ABC is false. First one, num a, that just means in the following definition a is one type of num. That sounds correct. B, that focuses on this part, and this means the function takes type A and returns exactly the same type. That sounds correct. C, this says this symbol and this symbol both represent type conversion. That is not correct, because this is the real type conversion from input which gets converted to output, and this symbol is just a separator between this piece of information and that piece of information, so it's really not that important, this separator symbol. Okay, more examples. Let's go back to our childhood. Let's compute a multiplication table, and let's get a list of numbers from 1 to 19. And then time tables has all these multiplication as a table. So how it works, we are using the list comprehension technique as we discussed in lecture 1. In particular, a is one thing from these items, so a is one of these items. Similarly, b is also one of these items. And then on the left hand side of this vertical bar, that is an expression, and here we say we have a, we have b, and we have a multiplied with b, and the ultimate output will be all such possibilities, and that means we'll have a as 1, then b1, b2, and so on. And of course this is the multiplication. Similarly, a as 2, b as 1, b is 2, and so on, and all other possibilities, right? The whole multiplication table will get by this simple technique. What is the value of this list? Here also we see the list comprehension technique, this vertical symbol and bunch of generators, right? A is getting generated from these possibilities, and there is also a condition that A is less than 5, and so that means ultimately from out of these two things, A can be 2, 3 and 4, right? So those values will come to this place one after another, and this is the expression. So that means the value of LST should be these 2 square 4, then 3 square 9, and 4 square 16, right? So A should be the correct answer. Another puzzle, what is the value of this list? Here we have A coming from this expression where this is an infinite list, and we are taking the first 4 items from this list, so that means 2, 3, 4, 5, correct? But there is an extra condition is less than 5, so only possibilities for A is 2, 3 and 4, not 5, and those possibilities will be here. So 2, 3 and 4, and they are squares, so B should be the correct answer. Now let's talk about anonymous functions. We already saw this in Scala, similar concept. Here first thing to notice that this is the way to denote an anonymous function. So here within this pair of parentheses, we have this anonymous function which starts with a backslash and then the parameter of the function. So backslash x means x is the parameter of this anonymous function. Then this arrow means whatever the function converts that parameter, that input, to this right hand side, which is the output. And here we see that nothing gets changed. The output is exactly same as input, right? So this is basically an unit function. So when this unit anonymous function is applied to this input here, which is a string, then the output should be also the same string, right? So so this is the output. So mind that this is basically the function, and then this is the input to the function, right? And that is how we are getting the output. Now let's take another example. Again, within this pair of parentheses, we have this anonymous function where backslash x means this is the input, and this part is the body of this anonymous function where input gets concatenated with captain. Now let's apply this anonymous function on this input, logical. So then you can mentally replace x with logical, and that means the output should be logical concatenated with captain, and which is logical captain, correct? Mind that comma was already there. Okay, which one is false? Y is this stuff, and as we just learned, this means y is an this right hand side is an anonymous function, right, where input is x, and this is the body of the function, that x squared plus 1, that is what this function returns. Now the type of y, that means this function, the function type is num a is a num, and this is the input to the function. That means a number is input to the function, and the same type is the output. Mind that there is a plus in this function, so only number type will work through this function. That's why input type is num and output type is same as num. So that means this statement is correct. The value of the expression y3, so this is the anonymous function, and then the input 3. So we are applying this anonymous function on 3, so we can replace x by 3, so that means 3 square plus 1, so 9 plus 1 10, and that will be the output, and that is correct, this B. Then this is the anonymous function, right? There is no name, so that is correct. The value of this expression y2, so the same function is applied on the input 2, so let's replace x with 2, so 2 square plus 1, so that should be 5. Here is 6, so D is the false statement. Now there can be different styles of saying same thing. So we know map takes an anonymous function and apply it on a list. Here the anonymous function takes one input and makes it square, right? Now instead of saying this way, we can also say the same thing in the following way. First we define square all, which is on a list, and that is same as applying square, applying map with square on that list, where square is defined as follows. So we can now say square all on this list, and that will be same as this style one. So square all basically means we are applying a map with square on the input, and that is what is happening here. Okay, now a fundamental concept in Haskell, and that is currying and partial functions. What is partial function in Haskell? When there is a function with multiple parameters, then under the hood, Haskell splits that function into multiple functions where each function has only one parameter. Let's take an example. Say prod is a function that stands for product or multiplication, which takes two parameters x and y, and as expected returns the product, and we can use that on 3 and 4, and as expected that will return 12. If you check the type of this function prod, then you will see some surprising thing. If this is the first time you are looking at this, so let's try to decipher. The type of the function prod is as follows. A is num type, and then this is the type information of this function. That is super confusing, right? A goes to A goes to A. We never seen something like that before. Now how to make meaning out of this? Let's proceed. So whenever you see some type information of a function like this, mentally visualize that as this. So that means after the first arrow, put an implicit pair of parentheses. Okay, so that means we are only talking about the function taking one parameter, and then we are trying to understand what is the effect of that. Now in this particular example, product taking 2 and 4, what Haskell does under the hood, first it consumes the first parameter 2, and that returns another function which is written here. So prod 2, prod after consuming the first parameter is basically another anonymous function which takes num as the parameter and returns the same type as the output. So prod2 is such a function, and then it will consume the second parameter 4. In more detail, prod2 actually returns this particular function. What is the meaning of this function? A function which takes one parameter and returns 2 multiplied with that parameter. If you think little more, the role of prod2 is something like that, right? And after this function we get, then it is time to consume the second parameter 4. So that means this anonymous function takes 4 as the input. So 4 will take the place of y, and then you will get the product 2 multiplied with 4, 8, right? In other words, you can also think this prod2 as you can name this prod2 as function double. That also is the same thing, correct? So the summary is, whenever there is a function which takes 2 parameters, Haskell splits that function into 2 partial functions. The first one is something like this, and then the second parameter is consumed by that first partial function and gives the ultimate output. Okay, think about it. And this concept is also called currying. Okay, now some examples of higher order functions. And fold right and fold left are very popular one. Let's take an example. So fold right can take one function f and one particular value z, and then it can take a list of items. And what fold right will do? Fold right will try to fold this list of items using this aggregation function f, starting from this initial value z. So in other words, first and it is fold right, so we start from the right of the list, the rightmost item c. So first we take c and apply this aggregation function f between c and z, the initial value which is given z and rightmost item c. So aggregation function f is applied on c and z, and whatever is the aggregation result, then another f works on that and the next item b, and we get another partial aggregation result, and then another f works on that and the next item a, and so on, and ultimately we'll get the aggregation result, right? Fold L is same thing, only difference is we start from the left end of the given list. So first f is applied on z and the leftmost item a, then this aggregation result and b are fed to another f, and so on. An example, say fold L on this list, and plus is the aggregation function, and we start from 0. So that means from left end we start, and this was the initial value. First this addition happens, then with addition with the next item, addition with the next item, and so on, and fold right does the same thing, but starting from the rightmost side of the list, right? Okay, so now let's focus on another higher order function, which is filter. And before going to filter, let's define one function called gt5, and this is the body. gt5 is the function name and x is the parameter, and this is the body. So what does the function do? Given a parameter, it checks whether the parameter is greater than 5 or not. If it is greater than 5, then it returns true, otherwise it will return false. So that is all this function gt5 does. If we check the type of this function, then this sort of information Haskell will show. That is, a is a num type, and also a can be ordered. So a supports numerical operations, and also a supports ordering operation. That is how you can interpret this part. And then this is the input output type of the function. So a is the input to the function gt5, and output is a boolean. As we saw here, it returns either true or false, right? Now we are going to use this gt5 function as a parameter to filter, because if you remember from our Scala lecture, that filter function takes one of such boolean returning function as parameter, and then it takes another list as the second parameter, right? So if you want to check the type of filter, then Haskell will show you this is the type of filter. How to interpret it? This is the first parameter which filter uses for the filtering purpose, like gt5, and then that filtering function is applied on an input list, and the output is also a list, right? As an example of this, here filter will apply gt5 on each of these items. Now when this function applies on the first item, we get false, because 3 is not greater than 5. When it applies on the next item 4, we get false again, then true here and false again. So only for this item 6, this filter function returns true. So only that item should remain in the output of the filter, correct? Okay, another example, lt3 x is x less than 3. So given a parameter x, lt3 checks whether x is less than 3. Filter applies lt3 on this list. So the type of filter, as before in the previous slide, will be this this lt3's type, which is this one, right? That is the filter's first parameter is lt3. So this is the type of lt3, and then lt3 is applied on an input list, and it also results another list, which is the output. So this is true information, statement A. Statement B is the type of lt3, that is obviously true, right? Then the value of y will be 2 and 1, because 2 and 1 are the only items for which lt3 is true, right? So C should be the correct answer, not D.